Have you ever wondered what it takes to be a data engineer? Well, you're in luck because data engineering is a fascinating field that involves working with large volumes of data to build, maintain and optimize data pipelines. Hello everyone and welcome to this video where we'll tell you all about how to crack data engineering roles in top product companies by Intellipaat. Data engineering is a critical function in today's data-driven organizations as it enables the processing and analysis of large volumes of data in a timely and efficient manner. With the explosion of data in recent years, data engineering has become increasingly important in helping organizations to extract insights and value from their data. But what does it take to become a successful data engineer? Well, there's no one-size-fits-all answer to that question. It all depends on your skills, experience and interests. And that is why we've outlined everything you need to know and get better at to make a career in this exciting field. So without further ado, let us take a look at the agenda for this video. First, we'll talk about what is data engineering. Then we'll look at the tools and skills required. Then we'll discuss the average salaries that are being offered by top product companies. Then we'll look at the typical interview process and questions asked. Then we'll look at the best ways to practice these questions and we'll discuss some tips and tricks, and with that we'll conclude. But before we begin, make sure you subscribe to our YouTube channel and hit the bell icon to receive regular updates from us. So first, let's talk about what is data engineering. Data engineering is the process of designing, building and maintaining the infrastructure and tools necessary for the collection, storage, processing and analysis of large volumes of data. It involves the use of various technologies including databases, data warehousing, ETL tools and big data frameworks to build reliable and scalable systems for managing data. Data engineers are responsible for ensuring that data is available, accessible and usable by other members of the organization, including data scientists, analysts and business users. They work closely with data scientists and analysts to understand their requirements and design systems that meet those needs. They are also responsible for ensuring that data is secure and that systems are designed to handle data in compliance with relevant regulations and policies. Now we'll move on to the tools and skills required. Data engineering is a field that requires a wide range of technical skills and knowledge of various tools and technologies. Here are some of the most important tools and skills for data engineering roles. Starting with databases, data engineers need to have strong knowledge of both SQL and NoSQL databases, as these are the primary tools used for storing and querying large amounts of data. Some of the most popular databases include MySQL, Oracle, MongoDB, Cassandra and Redis. Moving on to the ETL tools. ETL tools are used to move data from one system to another and transform it into the desired format. Popular ETL tools include Apache Spark, Apache Kafka and Microsoft SSIS. Next is big data frameworks. Data engineers need to be familiar with big data frameworks such as Hadoop, Apache Hive and Apache Pig. These frameworks are used to process large amounts of data in parallel across clusters of computers. Next is cloud platforms. With the growing popularity of cloud computing, data engineers need to have a good understanding of cloud platforms such as AWS, Azure and Google Cloud Platform. These platforms provide a wide range of tools and services for storing, processing and analyzing data. Next on the list is data modeling and architecture. Data engineers need to have a solid understanding of data modeling and architecture principles, including how to design and optimize databases and data warehouses. Moving on, programming languages. Data engineers should have strong programming skills in languages such as Python, Java and Scala. These languages are commonly used for building data pipelines and working with big data frameworks. Next is version control. Data engineers need to be familiar with version control systems such as Git, as these tools are used to manage changes to code and collaborate with other team members. Moving on, let's talk about agile methodologies. Many data engineering teams use agile methodologies such as Scrum to manage projects and collaborate effectively. Data engineers should be familiar with agile principles and practices. In addition to technical skills, data engineers also need to have strong soft skills such as communication, teamwork, problem solving and time management. They need to be able to work effectively with other team members and be able to communicate technical concepts to non-technical stakeholders. Now let's talk about the average salaries that are being offered by top product companies. The pay range for data engineering roles can vary widely depending on factors such as level of experience, location, company size and industry. Some of the top product-based companies include Amazon, Uber, Google, Microsoft and Netflix. So entry-level data engineering roles typically require 0 to 2 years of experience. The average salary for entry-level data engineering roles in India ranges from approximately 3 lakhs to 6 lakhs per annum, with the median being around 4.5 lakhs. Moving on, intermediate level data engineering roles typically require 2 to 5 years of experience. The average salary for intermediate level data engineering roles in India ranges from approximately 6 lakhs to 15 lakhs per annum, with the median being around 10 lakhs. Expert level data engineering roles typically require 5 plus years of experience. The average salary for expert level data engineering roles in India ranges from approximately 15 lakhs to 30 lakhs per annum, with the median being around 20 lakhs. And for data engineering roles in the US, the average salary ranges from approximately $65,000 to $90,000 per annum, with the median being around $75,000. The average salary for intermediate level data engineering roles in the US ranges from approximately $90,000 to $130,000 per annum, with the median being around $110,000. The average salary for expert level data engineering roles in the US ranges from approximately $130,000 to $200,000 annually, with the median being around $160,000. Now let's move on to typical interview process and the kind of questions that are asked. The interview process for data engineering roles generally consists of multiple rounds of interviews designed to assess the candidate's technical, analytical, and problem-solving skills. The process may vary depending on the company and the role, but here's an overview of the typical interview process for data engineering roles. The first round of interview process is usually a phone screen with a recruiter or a hiring manager. The purpose of this round is to evaluate the candidate's interest in the role, their qualifications, and their fit for the company. They are looking for clear communication, a pleasant person to work with, someone who's enthusiastic about the company and has done their research. Questions that could be asked in the interview include, tell me about your background, or why do you want to be a data engineer at our company, and what is your desired salary range. Then comes the technical interview round. It is typically conducted by a data engineer or a senior data engineer and involves questions related to data structures, algorithms, database concepts, data modeling, and data warehousing. The interviewer may also ask the candidate to write code or solve a coding problem on a whiteboard or an online platform. Some technical interview questions for data engineering roles include, what is the difference between a database and a data warehouse? What is normalization in database design? Explain the concept of ETL process. How would you optimize a SQL query for performance? What is your experience with distributed computing frameworks like Hadoop or Spark? How would you design a pipeline for processing and analyzing large volumes of data? Moving on, the next round would be a data modeling and design interview. The round focuses on evaluating the candidate's ability to design and build data models and databases. The interviewer may ask the candidate to design a database schema or optimize a query to assess their skills in data modeling and database design. Some of the questions for this round can include, what is the difference between a star schema and a snowflake schema? How would you design a database schema for a given use case? What are some best practices for designing databases that can handle large volumes of data? Moving on, the system design interview is designed to assess your ability to design and build scalable and reliable data processing systems. You may be asked to design a distributed data processing system, discuss various aspects of system architecture and design, or explain how you would approach a particular system design problem. Some sample questions for this round could include, how would you design a distributed system for processing and analyzing large volumes of data? What are some of the common issues that arise in distributed systems and how would you address them? Next, what are some common design patterns that you've used in your previous projects and how did they help you solve problems? The next round would be a behavioral interview round. The behavioral interview is designed to assess your soft skills, communication abilities, and work experience. You may be asked questions related to your past projects, teamwork, leadership, and problem-solving skills. Some sample questions for this round could include, tell me about a time when you had to solve a complex technical problem. How would you approach working with team members who have different skill sets and backgrounds? Describe a project that you worked on where you had to make trade-offs between competing priorities. Next is an on-site interview. In the on-site interview, you may be invited to the company's office for a day-long series of interviews with various members of the team, including managers, engineers, and other stakeholders. The on-site interview is usually the final round in the interview process, and it's designed to assess your fit with the company culture, team dynamics, and work environment. This round may include more in-depth technical questions and problem-solving exercises than the earlier technical round. Next is design round. This round may focus on your ability to design and implement complex data systems and may involve whiteboarding or sketching out system architectures. Next is a managerial round, and this round may be conducted by a hiring manager or a senior leader and may focus on your fit with the team, your communication skills and your leadership potential. Now let's talk about best ways to practice these questions. To prepare for data engineering interview questions, there are several ways you can practice. Starting with mock interviews, practice mock interviews with friends, colleagues or online platforms. These platforms offer mock interview practice sessions with real interviewers from top companies. Next, practice on coding challenges. Use online platforms like LeetCode or HackerRank to solve coding challenges and data engineering problems. These platforms offer a variety of problems in different categories such as databases, data pipelines, algorithms and more. Next is study job descriptions. Look at job descriptions for data engineering roles and take note of the skills and technologies required. Then study those skills and technologies to make sure you understand them and speak about them in detail. Next is building personal projects. Build personal projects to apply what you've learned and gain practical experience with data engineering tools and technologies. This will also give you something to talk about during your interview. Next is joining online communities. Join online communities like Reddit, Quora or LinkedIn groups to discuss data engineering with others in this field. This may help you to stay up to date with the latest trends and technologies and learn from others' experiences. Moving on to tips and tricks, starting with developing your programming skills. Programming skills are crucial in data engineering and you should have a good understanding of programming languages like Python, Java and Scala and know how to use them to manipulate data. Next is mastering database technologies. As a data engineer, you will work with databases every day and it's essential to have a good understanding of database technologies like SQL, NoSQL and Hadoop. Data engineering involves solving complex problems and you'll need it to be able to think critically and creatively to find solutions. Practice problem solving exercises and puzzles to develop these skills. Next is staying up to date with latest technologies and tools. Data engineering is a rapidly evolving field and it is essential to stay on top with the latest technologies and tools. This will not only make you more valuable to your employer, but this will also help you stay ahead of the competition. One way to cover all this is to enroll for Intellipaat's data engineering course. Intellipaat's data engineering course by MIT MicroMasters is an excellent training program designed to equip learners with the essential skills needed to excel in data engineering. With a comprehensive curriculum, expert instructors and hands-on learning opportunities, this course is perfect for anyone looking to build up a career in this field. Our expert-led training is one of the key features of the program. Our instructors are experienced data engineers who have worked with top companies and can provide personalized guidance and support to each learner. You'll also have access to a vibrant community of fellow learners where you can connect, collaborate and learn with other learners. The course covers a wide range of topics including data modeling, ETL processing, data warehousing, data integration, data migration and much more. You'll get to work with popular tools and technologies like Apache Hadoop, Spark, Kafka and SQL. Our hands-on approach to learning will allow you to apply what you learn in real-world scenarios, giving you the confidence and skills needed to succeed in your career. In conclusion, data engineering is a fascinating field that offers a world of opportunities for those who are passionate about data and technology. With the right skills and mindset, you can build a successful career as a data engineer and help shape the future of data-driven innovation. Not only is data engineering an exciting and challenging field, but it also offers excellent compensation packages and job security. According to recent salary reports, data engineers are among the highest paid professionals in the tech industry, with salaries ranging from entry-level to six-figure incomes for experts. Moreover, as more and more companies embrace data-driven decision-making, the role of data engineers has become critical, ensuring the accuracy, reliability, and efficiency of data pipelines. This means that data engineers can expect to have a stable and secure career with plenty of opportunities for growth and advancement. In short, data engineering is a field with immense potential and endless possibilities. Whether you're just starting out or looking to take your career to the next level, the future looks bright for those who pursue this exciting and rewarding career path. So why not join the ranks of skilled data engineers and unlock your full potentials? The possibilities are endless. With that, we come to the end of this video. Thank you for watching.